Okay, I have an apology for all of you guys. The first video, I mentioned it was going to be the longest. This one's going to be the hardest, okay? This is the material that usually causes the most problems. So let's get straight into it. We're going to talk about function compositions. Function compositions is basically plugging functions in to other functions, okay? So if I have one function that takes me from Fahrenheit to Celsius, and another function that takes me from Celsius to Kelvin, I can combine those functions to get directly from Fahrenheit to Kelvin. That's the sort of idea behind function compositions. So let's write that down explicitly. The definition of this function composition is f of g of x, and that's a tiny little circle. It's not an O. The little open circle, like a hollow multiplication sign, is equal to f of g of x. You just find whatever g of x is and plug that result into the function f. All right. So let's see it in action. Okay. We got example 4 over here, assuming I'm counting right from the earlier videos. For f of x equals x squared plus 1 and g of x equal to the square root of x, find the following. Part A, what is f of g of 4? We just use the definition. F of g of x is f of g of x. So this is going to be f of g of 4, which looks nasty. But all we have to do is start on the inside and work our way out. Like the little aliens from that movie that explode from your chest and kill you. So we need to find out, what is g of 4? Well, g of 4, just what happens when you plug 4 into this function. Well, that's the square root of 4. That's g of 4. So since they're the same thing, just replace the g of 4 with the square root of 4, right? G of x equals the square root of x. So g of 4 is the square root of 4, which is 2. Let's simplify that a little bit. Square root of 4 is 2. And voila, that's it. Well, we're not done with the problem, but that's the hard stuff, right? Now it's just f of 2, and all of you know how to find f of 2. You just plug 2 into f. So that's going to be 2 squared plus 1. That's 5. So that's what we're doing. Write out the definition. This is the first big step. And then evaluate the inside. Okay? Do another one. F of 0. Again, they can be the same function. That has meaning too. Okay? It's just the same idea. So now instead of f of g of 4, now it's going to be f of 0. And again, you just start with the inside. Right? We said that f of x is equal to x squared plus 1. So what is f of 0? Well, that's going to be 0 squared plus 1. F of 0 is just positive 1. Since f of 0 is 1, we can replace it with what it equals. If two things are equal, we can interchange them at will. Okay? F of 0 is the same thing as 1. So in this line, I wrote f of 0, and on this line, I just wrote the 1. They are exactly the same, which is why we've got this nice equals sign. Okay? And now all that's left is to find what f of 1 is. So again, f of x, we've got that over here. F of 1, we just plug in 1. It's going to be 1 squared plus 1. Simplifies down to 2. There we go. That's all there is to it. Okay? So when it's numbers, not too bad. Just start on the inside, work your way out. It's when you don't have numbers that things get more exciting. So part C is where things are really going to pick up. Okay, so before we go on to part C, recall, right? If I ask you what is f of a, you just plug in a. You get a squared plus 1. If I asked you what is f of a plus 1, you just plug in a plus 1. You're going to get a plus 1 squared plus 1. You're just plugging it into the function of here. If I asked you what is f of x plus h, well, you just replace the x with x plus h. Okay? Just like so. So that sort of thing is going to be really, really important here. Okay? We need to incorporate this into these definitions. All right, so what we've got here is part C. What is f of g? You go off the side, remember f of g is the same thing as f of g of x. Feel right. Okay, we need to find f of g of x. Well, using the definition, that is just f of g of x. Now we can't evaluate g of x. But, again, I want to make sure these are always written down in plain view. These are the f of x and the g of x's from before. I can't figure out, oh, g of x is some number. But I do know g of x is the same thing as square root of x. So we're still going to start on the inside. G of x is the square root of x, so we can just replace it. G of x is the square root of x. Instead of writing g of x, we're going to write what it equals, square root of x. And the f still is there. Now here's the big step that can get you. Just like in these things we've done before, we need to now plug this into f. F is something squared plus 1. Right? That's what the function f is, something squared plus 1. But we don't have f of x over here. We have f of the square root of x. So instead of writing x, we plug in the square root of x. Just like up here. Instead of x, we had x plus h squared. Instead of x, we had a plus 1 squared. Instead of x, we had a squared. You just replace all of the x's with whatever you have on the inside of this f. And now we can simplify. Square root of x squared is positive x plus 1. And again, this does look like it changes the domain, but we address that later on in this video. This is our answer. It's just x plus 1. Okay. Another one. Part D. FOF. Find f of f. Again, you go off to the side and say we really need f of x. That's f of x. Start on the inside. What is f of x equal to? X squared plus 1. And now we need to plug that into f. Replace all the x's with x squared plus 1s. We have x squared plus 1 squared plus 1. Look at the function. Place all the x's with whatever you have on the inside. So instead of x squared, it's x squared plus 1 squared. And now we can simplify. So we'll be using that formula shortcut for perfect squares of binomials. X to the fourth plus 2x squared plus 1, or just x to the fourth plus 2x squared plus 2 is our final answer. Okay? And that's one of the big tricks. I was going to pause for any questions, but I always forget that when you record videos, people cannot ask questions. But if you do have a question right now, pause the video, get on Slack, and ask me, okay? It all works out. All right. So that's function compositions. Now we need to talk about domain. Okay? For f plus g, f minus g, f times g, we just found the intersections of their domains. But for composition, it's a little bit more complicated. On fire today. All right, we got some good puns. The property. The domain of f of g is the intersection of, it doesn't really fit. All right, it fits now. So it's still the intersection of two sets, just different sets. First one is the domain of g. Specifically, g right here is the inside function. And we need to intersect that with the domain of the simplified f of g. So that's kind of a weird, confusing thing to say, the domain of the simplified f of g. But let's kind of look at this. So for the previous one, for this one, f of g, The domain of this resulting function, f of g, is going to be the domain of the inside function. So the domain of this was 0 to infinity, intersected with the domain of what it looks like at the end, which is all real numbers. So the domain of this function actually is 0 to infinity, even though it doesn't look like that would be the domain. You have to intersect the domain of the inside function with the domain of the simplified function. Okay? So you're still going to get 0 to infinity, even though it looks like it simplifies away. And this is another really confusing part of the section, okay? So feel free to ask me questions on Slack or email if you're having trouble with this, because I can only explain so much to a video and assume what you're getting or not getting, okay? So let's just do some problems with this. We're going to do 2 problems like this. Example 5. It looks like a 6, but it's a 5. Don't fall for it. For f of x equals x squared plus 1, and g of x equals the square root of x, and let's say we also have an h of x of 1 over x minus 1. Find the following and their domains. Part A is going to be f of g, fog. All right, so you say, okay, well, f of g of x is equal to f of g of x. That's just the domain, the definition of function composition. Okay, and now we need to say, what is that inside function? Well, the inside function is the square root of x. And as soon as we plug in the inside function, we go, oh, the domain of f of g is the intersection of 2 different domains. Domain of inside function. What is the domain of this inside function? The domain of this inside function is 0 to infinity. So this is one domain that we're going to have to intersect with a different domain. Okay. Oh wait, this really is just the previous problem I was talking to you about. Anyway, now we plug this into f. So everywhere that there's an x, we replace with the square root of x. So it's no longer x squared, it's the square root of x squared plus 1. And again, this simplifies. Square root of x squared is just x plus 1. So what's the domain of x plus 1? X plus 1 is a line. Domain of x plus 1 is negative infinity to positive infinity, all real numbers. So to answer our question, again, this is part of our answer. What is f of g? We just need to find the intersection of these two intervals. Intersection of intervals. Okay. We have to say, okay, well, we got 0 to infinity looks like this. Negative infinity to positive infinity looks like this. What is their intersection? Well, it's what they have in common. And that's going to be 0 to infinity. All right, and that's our domain. So domain of f of g is just 0 to infinity. And that's our second answer. Found the function, found its domain. The domain of function composition is just the domain of the inside function, intersected with this final simplified version. Okay, let's do another one. Part B. Finish off this section. Let's find the domain of hog, h of g. So you say, all right, first we need to find h of g. H of g of x is going to be h of g of x. And again, we need to find that inside function. Inside function is the square root of x. G of x is the square root of x. As soon as we know the inside function, we say, oh, what's the domain of that inside function? 0 to infinity. It's the same inside function as last time. Okay. Now we plug that into h. What is h? 1 divided by x minus 1. Replace all the x's with what we have on the inside. So instead of 1 divided by x minus 1, it's going to be 1 divided by the square root of x minus 1. And now we have to say, okay, what's the domain of this simplified function? Well, now the domain of this simplified function is going to be, well, we still need x to be positive, and we need the denominator not to be 0. Right? We need x to be non-negative, and we need the denominator to not be 0. And it looks like there's no problem. Great. So when is this? This when the square root of x is not equal to 1, square both sides. That's when x is not equal to positive 1 squared, which is just 1. So x is greater than or equal to 0, and x is not equal to 1. Notice that, by the way, that these two requirements are the same. So now intersect all of this together. And again, this was our answer for what is h of g of x. Intersect everything together, 0 to infinity, and not 1. It's going to be 0 to 1, union 1 to infinity. Okay, and that's how we find the domain. Okay, again, this is tough. If you have questions, reach out to me, all right? Otherwise, good luck.